Okay, now your homework for today was on transformation, so everybody should understand what to do with these, okay? This shifts the graph 10 units to the right, because you replaced x by x minus h, and h is tenths. This shifts the graph 10 units to the right. How big is 10 units? Well, 10 units. Would we have you in that other chair? Yeah, okay, it's okay. We can always switch chairs, that's fine. Or switch positions, okay? Okay, so we shift 10 units to the right. What's a shift 10 units to the right? Well, this is plus 10 units. So we just take a few key points of this graph, maybe the peaks and the valleys, and maybe the x-intercept, and maybe a point out here. Then we shift each one of these points this far. So let's see, this one would go to here. And this one would go to here. And this one would go maybe to here. And this would go maybe to here. And then we simply, and maybe we take one of these low points over here and shift it over to here or so. And then we just draw a curve through the points that we get. And it's going to look a lot like this curve, but it's going to be 10 units to the right. That's what happens. Okay. Now, if we do f of x plus 10, well, every y value is going to be 10 more than it was for f of x, right? So, oh, where's my chalk? Okay. We use this color. It's 10 units vertically. Now, you should be used to shifting graphs because we spent almost a month learning to shift graphs of toolkit functions. But nobody's really still appears to have mastered that idea. Okay, so number one, try to find time to learn stuff in this course. Make sure you're setting enough time aside and get the assignments done. I know life can sometimes interfere with that, but okay, we shift 10 units vertically. What's 10 units in the vertical direction? Well, this is y equals negative 10. This is y equals 0. So this is plus 10 here. So we go that far here. Go that far here. Go that far here. Same thing here. I went too far. Same thing here. Oops, that's the wrong point. Same thing here. Okay, then I got a point here, a point here, a point here, a point here, and a point here, and I can sketch a nice curve through these points, and it looks a whole lot like this curve, but it's 10 units higher. And that's all there is to this, okay? But of course, if you haven't done the assignment and haven't picked up everything that we did in the first few weeks, might be a little bit challenging. Now, the stretching is something that we haven't done that much with, but we're starting to, okay? Matter of fact, we're going to do quite a bit with it. 2f of x. Well, this means we're doubling the values of y. Okay, so this doubles y values. So what's the y value here? Well, let's just take here. We can represent the y value by an arrow. Okay, that's the y value for whatever this value of x is. And here's another y value. And looking at the original curve, so I don't get myself confused again. And then there's one here. These are the y values. How do you double the y values? You add another arrow that represents the y value. This doubles the y value. Gives me a point here. We add an arrow equal in length to this one. We add an arrow equal in length to this one. We add an arrow equal in length to this one. And now we've got points here, 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 and here, each one with twice the y value. And we get something that looks like this. It's got the same type of shape as the first one, but it's more extreme. Everything moves twice as far in the y direction. It's as though we took the whole xy plane and stretched the y-axis out double. If we do -2 f of x, well, it doubles the y values, but then reverses them. Now, I'm not going to do that on the picture because it's going to get too complicated, but it's just going to turn this curve, flip it over the y-axis, or flip it over the x-axis, okay? Well, there's that. Now, the task here is just function notation, okay? Okay. X has been replaced by x minus 10. We take this formula and replace all the x's by x minus 10, and we get the formula for f of x minus 10. Matter of fact, we get the whole equation here. This x is replaced by x minus 10. This x is replaced by x minus 10. So that's all we do. We just blindly replace all our x's by x minus 10. And this gives us x minus 20 times x minus 8 squared. Now, if this was the graph of this f of x, then the graph of this f of x will look something like the graph that we just had. Then we know what happens to the graph. If the white graph is the graph of this function, and the graph of this function is quite like the white graph, but it's very similar, okay? Then the graph of this function is going to be the orange graph, the one that was shifted 10 units to the right. Then f of x minus 10, well, f of x is x minus 10 times x plus 2. This is f of x, right there it is, okay? And then we slap a minus 10 on it. All right. Now we could do things. We could expand this product. Get x squared minus 8x minus 20 minus 10, so that's x squared minus 8x minus 30. And that would be, oh, wait a minute, it was f of x plus 10, I wrote f of x minus 10. Okay, it was minus when I wrote it, but I'm going to do plus 10, so it corresponds to one of these graphs. Okay. So, okay, anyhow, this function would then be represented by the purple graph. Every point raised up 10 units. Now, 2 f of x minus 10 plus 12, well, that's going to be a little different. It's not really going to correspond to one of these, but you got, okay, if this is a graph of f of x minus 10, we double every value, and boy, I screwed up, no, I didn't. Okay, yeah, we double every y value of the orange graph, and that gives us f of x minus 2 f. Gonna do it right here in a minute. Okay, what we do is we double all the f of x's, and then we shift it 10 units. So it's like we double all the f of x's, it gives us the what color is that? Yellow graph, okay? And then we shift it 10 units to the right. So take this yellow graph, pick it up and move it this far to the right, and that would represent the graph of 2 f of x minus 10. And then plus 12, well, we've taken that yellow graph and shifted it to the right. Now we've got to move it up 12 units. Let's grab the whole thing, move it up 12 units. Okay, so what's the formula that goes with that? It's 2 f of x minus 10 plus 12. But we already have the formula for f of x minus 10. So it's going to be x minus 20 times x minus 8 squared. Okay, this is our f of x minus 10. It's going to go here. We're going to put a 2 in front of it, and then we're going to do plus 12. Now we do a little algebra and we'd simplify this and get it in the form of a polynomial, but we're not doing polynomials right now. Okay, we won't do polynomials for 2-3 weeks. But all the stuff you've learned about function notation, shifting, stretching, transformations, all the stuff that was due today, if you haven't done it, you better do it. And you know, gives you a picture. It's not hard to develop this picture. Some of you actually did fairly well with this. And this is actually easier than this, because here all you got to do is plug things in. You just got to understand function notation, which takes practice. Okay. If you haven't had enough practice, please find the time to start practicing. It's not too late, but it's getting to be where it could get that way soon. Okay, because we're about to move in to the real course. All right. So some of what I saw out there is promising, and some of it had me a little concerned. But it's up to you to get the work done. Please get it done. I want everybody to do well. I like y'all. But I don't want to give people bad grades. Okay. It's not like I'm giving you grade. You're getting the grade you earned, but on the good grade. Oh, yeah. Let me get the boards arranged here. Okay, I'm going to give you a quick premonition of the first place we're heading and what we're really aiming for. Now, we're not there yet, but you should be able to understand all this if you understand everything we've done in this course. Okay? Or understand most of it. The more you understand, the more you've done, the better you're going to understand what I'm telling you. So hopefully this will click, but I would recommend that you kind of make yourself a note of where this is so you look at it every once in a while. Now, if you want to look at it in more detail, you can look at it the way I presented it in the MDE 61 class. Those links are right there. Okay. And we went over it in some detail. Quadratic functions, which is the first thing in our course that I think is really what I would call pre-calculus. Everything else is just algebra 2, high school math. Okay. Now, not everything. The whole thing about transformations and so forth, that's, you know, pre-calculus level. But the stuff in linear functions is stuff that should be done well before you get to a pre-calculus course. Anyhow, this is what really starts, and this is kind of the last thing we do before the midterm. Okay. So quadratic functions. Now, quadratic function is represented by a vertically stretched, vertically shifted, horizontally shifted basic toolkit squaring function. Now, what I just say? I said vertically shifted. Sorry, vertically stretched. We did that with those graphs and stuff, right? You know what that is, we should. And horizontally and vertically shifted. We've been horizontally and vertically shifting things for a month. Okay. So these are concepts that you should really understand at this point. And if you're going to ever pass this first test, you need to understand them. Okay, now this gives us the function g of x equals a f of x minus h plus k, which we've talked about extensively, okay? So if you've been reviewing the notes and reviewing everything and being able to do and preparing for the test that was due a week ago, or a couple days ago, actually, but, and most people didn't take, you would know this, you know what this means, okay? So I'm telling you, you need to learn what this means so you understand what I'm telling you, because this makes everything really easy if you understand what we tried to develop in 3 weeks, 3.5 weeks, whatever it was. Okay, the AF of x minus h plus k thing. There's your vertical stretch. There's your horizontal shift. There's your vertical shift. Okay, you apply this to the f of x equals x squared function, which is your toolkit squaring function, which you would know from the very first section of chapter 1, and which you constructed well before we ever assigned section 1, okay? Which you should know how to construct. 4 by 4 squared, divided so there are 5 lines vertically, divided toward the bottom so there are 5 lines horizontally. Start in the upper left-hand corner, over 1, down 2, over 1, down 2, over 1, down 2, then over 1, up 1, up 2, over 1, up 2, over 1, up 2, and you got a nice parabola, okay? Gotta know those rules, gotta know how to divide that, and you will have to know that throughout the course. Okay. Gives us this function. Now, what's that mean? Well, I did this for the benefit of people in the other sections, because everybody in this section should understand it totally, except for the vertical stretch thing. So vertical stretch, we start with the y equals x squared. That's the white graph. And then we make this square a little higher. Okay, we vertically stretch it. We stretch it out this way and we get blue function. Okay, now the amount by which we square it, or the factor by which we stretch it, I mean, okay, the factor by which we stretch it is our value of a. So stretch it out. A looks like it should be about 1.5 here. It's about 50% higher, maybe 60%. Okay, so we stretch it out. A is like maybe 1.6 then. Then we just shift it, shift the red dot. You know exactly what I mean by that, and everything else goes along with the red dot. The whole plain rectangle goes along with the red dot. Okay. Now, if a is less than 0, we haven't really talked about that, but your assignment covered it. And you should, if you've done everything, be able to understand that pretty quickly. Okay, we just flip it upside down. A is a negative number. Okay. So if a was a negative number, we'd flip it upside down and stretch it. That's a reflection through the x-axis. And then we shift it. And there's our graph. And in each case, this would be the graph of a. Times. Just inhaled something. Bit of food between my, you don't need to know, but it's sucked it down into the lower levels of my lungs. Okay. Now, careful, if you got a unique laugh, you can't laugh in here. Now, you can laugh. Nobody's going to identify you from the laugh. It makes me think of Van Keys, who had the most unique laugh in the world. Anybody could identify him from that. But as an instructor of theater here, really interested in that. Okay. Whatever I was saying before I tried to choke myself. Yeah, I don't remember what my train of thought was. Anyhow, we'll get these graphs. Okay, all that should be familiar. And then the whole idea of flipping over the axis. In many ways, you can see how that works. Okay, now open math is fond of doing things that you can do in your calculator, and I'm not. Okay, had a student And he's an experienced student. He's not old, but he's probably still in his twenties, but he's a little older than students just out of high school. He's had some serious mathematics. He's taken my physics course. He was commenting that he read that in China and India, they never use calculators. And they preferably do it in their head. I'm not sure how we're going to keep up with China and India technologically. All this emphasis on calculators just so parents can feel like their students are doing something, don't have to really work very hard. Okay, it really comes down to that, catering to, and I'm not sure exactly what it comes down to, but it appears to me to be a catering to a really bad idea. Okay, I mean, people want their kids to have some self-esteem, but boy, you can get that out of balance, and I think maybe that's happened. I don't know all the details, so please understand why I discourage the use of calculators and why I started this course by constructing these graphs with no reference to numbers whatsoever. And I never referred to a formula until the day before you had the first open math assignment, okay? About 3 weeks into the course. These graphs are what they are because of the way they're constructed. That's our idea in this course. And if you take that idea and put it together and do everything and learn how to construct these graphs, which everybody should have been able to do after the first week. Still very few people can do, okay? You have a perspective and an insight into this. Please develop that insight if you don't have it already. Okay, some people do. There's some rules and it takes some practice. That's all it takes. Everybody can do it. But if you can't do it, it's because you haven't practiced it sufficiently. Okay, so G of X would be this. Okay, just repeating the form we have here, coming from what we just talked about. G of X is this. It's the f of x equals x squared function, vertically stretched by factor a, horizontally shifted h units, vertically shifted k units. We apply the distributive law to square this. It's not x squared plus h squared. It's not x squared minus h squared. It's x squared minus 2xh plus h squared, which everybody should totally understand when they come out of an algebra 2 class. Okay? But most people don't, so we got to take a little time to do it, but we're not going to take a lot of time. I expect you to be able to use distributive law when it applies, okay? I'll talk about it, but I'm not going to talk about it repeatedly just because we don't have time. All right. You do this, and then you multiply through by a, and then you put it all together, and you find that you have something times x squared, and that's still a. Your vertical stretch still lives here, right in front of x squared. Then you have a multiple of x. You got 2axh. That's just x multiplied by negative 2ah. Okay, well, that's what we're going to call b. And then the h squared plus k is your c. You don't have to understand it. You don't have to know that this is h squared plus k. You don't have to know this, although it's kind of good if you do. Then we got g of x equals ax squared plus bx plus c. The vertex is at the point hk. On the vertical line, x equals negative b over 2a. Why is it at hk? Well, it's at h because b is negative 2ah, and if you divide that by 2a, you get h. Okay? That's why. And as I said in my MDE 61 class, you don't totally have to understand that right now. But if you do, it's really good. Okay. So you get this, and this is called the axis of symmetry. So everything I've done here tells us that if you have a g of x in this form, or in the form ax squared plus bx plus c, sorry, in this form, then your axis of symmetry is at negative b over 2a. That's the axis of symmetry. So I'll give you this function. Here's a quadratic function. I should know that quadratic expression is like ax squared plus bx plus c. I'll write that. Actually, maybe I'll just emphasize that. So when your function has this form, this is your axis of symmetry. So what is b here? Well, it's 6. It's what's in front of x. It's a coefficient of x. You divide that by 2a. What's a? It's a coefficient of x squared. What's a coefficient of x squared? It's 1. So you do negative b over 2a with a equal 1, b equals 6, and c is your negative 12 there. Okay, we don't need that for the axis of symmetry. And you get the formula for the axis of symmetry, which is x equals negative 3. Now, why have I been asking you to sketch the vertical and horizontal lines and label them? Partly it's to get used to what vertical and horizontal lines are and what they mean. Partly it's to give you an orientation to the scale of your graph. But there are very good reasons for having done that, one of which is that we can now sketch the line x equals negative 3 without having to look up how to sketch the line x equals negative 3. The line x equals negative 3, now there's a bunch of stuff here that, if you want to see where it came from, go back to the MDE 61 and spend 10 minutes seeing how all this was developed. But x equals negative 3. How do you get x equals negative 3? On a graph, you put a line to the left of the x, y axis, and you call it x equals negative 3. It's a vertical line. Okay, so what do we know? X equals negative 3 is your axis of symmetry. Now, here it is. I'll kind of make it red within the figure. We just started out with this. With x equals negative 3, we said the vertex is on this line. Because the vertex is at HK, which you will understand perfectly if you did everything or even half of what we did in the first 3 weeks. Okay? Vertex on the line x equals h. And h in this case is your negative 3. Then we construct our graph. Now, this worked out really nicely. We first of all say, well, our red dot is on this line when x equals negative 3. Now, what's the y coordinate of the vertex? Because in order to put your red dot on this line, you got to know what the y coordinate is. Well, you plug negative 3, you do g of negative 3, meaning you replace x by negative 3. So g of x is x squared plus 6x minus 12. Axis symmetry is x equals negative 3. G of negative 3, we just plug it in and do the arithmetic and you get negative 21. Okay, so now we draw the line y equals negative 21. Then we construct the graph in this little squashed down rectangle. It's squashed down because the y scale, this is 21 on the y scale, this is 3 on the x scale. Scales are different. We want a 4x4 rectangle. Okay, because a is 1 in this case. There's no vertical stretch because x squared always has a in front of it. A is your vertical stretch. And if the vertical stretch is 1, it means you're not stretching it anywhere. If it's bigger than 1, you stretch it this way. If it's less than 1, you squash it down. Well, we decide what the lines are that bound our rectangle. If y is negative 21 here, then your rectangle will have a bound of y equals negative 17 above because it's 4 units high, and 4 units higher than negative 21 is negative 17. And 2 units to the right and 2 units to the left of negative 3 is negative 1 and negative 5. So right here is your rectangle. That's not drawn very well. It's actually drawn fairly well here. which is a little surprising. And just to mimic the colors on the graph that I have up here, I used purple. And of course, we could construct this with all the lines and everything. But there it is. There's a parabola constructed within this rectangle. Now, I constructed a parabola within the rectangle here. Here's my line y equals -17, y equals -21. Now you can kind of look at this picture and see what we've got. We've got x equals -1 here, x equals -5 here. X equals -3 here, which is your axis of symmetry. And there's the graph within the rectangle. Now, what happens outside the rectangle? Well, I can just follow the trend. This thing keeps getting steeper and steeper. So it's going to come up like this. It'll come up like this. It's going to keep going, right? It's going to get very steep. Goes through the x-axis here. It goes through the x-axis here. Well, I did that here. I extended it up here. So it goes through the x-axis at this point, goes through the x-axis at this point. How did we test where it goes through the x-axis? We tested it by, how do we find where it actually goes through the x-axis? Well, on the x-axis, y is 0. These are the x-intercepts. X-intercepts occur when y equals 0 because on the x-axis, y is always 0. So I can say if y equals 0, well, y equals g of x, and g of x is x squared plus 6x minus 12. And you set that equal to 0, and you use the quadratic formula. Now, y'all seen the quadratic formula. You might not remember it, but we did this in the MDE 61 where we just looked at the quadratic formula because we worked a little ahead in that course, but not going into all the depth, okay? So the quadratic formula gives us this, and that's easy. It's very easy. So whether you remember the quadratic formula or not, as soon as you remember it, it's very easy to find this. And I find that, I did a pretty good job of estimating where this goes. Okay. But not very good or anything, because usually I don't. I just lucked out. All right. Then we have other characteristics of the graph. Where's the y-intercept? Well, it occurs when x equals 0. Now you got to know these things. You got to know that the x-intercept occurs when y equals 0 and the y-intercept occurs when x equals 0. And now that you know that, you can do this. And we got a couple of weeks before we actually hit this, but I wanted to give you a preview because I kind of like the way it came out in the MDE 61. And it also helps you understand why you need to understand everything that we did up through the first test. You're going to have an assignment this weekend, extra assignment. Okay, so that should be easy if you understand everything. And if you don't, it should help you understand everything. Okay, but it'll be a little harder, take a little more time. I don't like to give extra assignments during the week because you only got 2 days. On the weekend, you got 5 days. Hopefully you got time to do it. Okay. Well, that was fun. And then we did some more stuff. Now, I really wish I watched these boards when I had a chance. But we'll do what we can. Or I have to talk more before. We want to talk now about something much simpler than all this. It's just linear functions. Okay. And linear functions are simpler, but there's still a lot of stuff you got to be able to know and be able to do with it. I'm going to give you a quick survey, but you shouldn't have any trouble with this assignment. We have a lot of pretty smart people in this class. Put the time in up, you're going to get it. Okay. Some people might have a little trouble with it. Linear functions y equals mx plus b. That's one form. This is called the slope-intercept form. There's another form. This is the point slope form. First of all, let's do line through 0, 6, and 4, -2. Okay. Now, presumably, you can easily sketch because we've been doing a lot of sketching on coordinate plane. Another thing, another part of my reasoning in doing the course, starting the course the way we did was to get you really used to the coordinate plane. Okay. Want you to sketch a line for y equals 6. Now, y equals 0 is just your, sorry, x equals 0, just your y-axis. We'll just say, okay, x equals 0, just to remind ourselves. And then 4, -2. Okay, where do you want 4? I'll put x equals 4 out here. And then y equals -2. How big is -2? Well, 6 is this big. How big is -2? Well, less than half, a little less than half, it's about that big. Well, 2 is about this big, so -2 would be about here. So here's y equals -2. I think you learn more by sketching the lines that you need in order to construct the graph and estimating where they ought to be than you do by marking off your graph 10 units this way, 10 units this way, which takes some people 5 minutes. Okay? Let's just understand what the numbers are and estimate them. If you need a precise graph, you can always go to graph paper, but we don't use it in this course. Now, open math gives you grids. I don't like giving people grids, but the way open math is, you got to do it on the computer. You almost need it. Okay. So I don't quibble with them on that. I just think it's unfortunate. We have to do that. I want them drawn. I want them sketched. Okay. Now, where's the point 0, 6? It's where the line y equals 6 intersects the line x equals 0. There. Where's the line 4, -2? It's where the x equals 4 line intersects the y equals -2 line. It's here. And then we draw a straight line. I kind of missed, but I had a bad angle with the board. It's not because I'm incompetent. Well, maybe a little bit of both. Okay. Now, how do we get the slope? We draw a fundamental triangle. That's how we got a slope in this course. We don't use the slope form. We don't do it by calculating without any meaning. We sketch the blamed meaning. Okay? And the meaning is simply, well, we draw an arrow and another arrow that takes us horizontally from the leftmost point to the rightmost point. And we see that our run is 4 and our rise is -8. Okay. Now, normally I would calculate these. You've seen me do it, and that's part of the labeling. When I ask you to completely label a fundamental triangle, this is what I mean. You don't just tell me that the run is 4. You tell me that the run is 4 minus 0 equals 4. You tell me that the rise is -2 minus 6 equals -8, which reinforces a lot of things. Then we have the hypotenuse. I keep missing my line. Yeah. Okay. And the slope is rise divided by run, which is -8 divided by 4, which is -2. And we put the -2 in a box here. You've seen me do this several times. Make sure that you know how to label this, because I'm going to ask you very likely on a quiz next time and give you about 10 seconds to do it. Okay? I'll give you more than 10 seconds. Limited times. You need to know how to do that. Practice doing them. Just make up a bunch of points, draw it. Make up a bunch of points, draw it. Okay? Put a bunch of numbers in a hat, pick them out for your points. Okay? Whatever. It's practice drawing fundamental triangles so you know what a slope means. It's not just a formula. Okay? It represents on a graph and it's got important interpretations, especially rate of change. And we did a lot of this when we did rate of change a couple of weeks ago. Okay? Now, maybe last week, maybe earlier last week. Anyhow, there we have our fundamental triangle. Okay, well. Okay, so the slope of our line and let's remind ourselves that M is the slope. And I didn't say that. So I probably should. M is a slope. The y-intercept is at the point 0b. All right. So now that y equals -2x plus b. So we're on a roll here, aren't we? Yeah. How are we going to find b? Well, the y-intercept occurs at 0b, and look at what I did. I gave you the point 0.6. I gave you the y-intercept. It's the coordinate form of the y-intercept, so v equals 6. Thus, y equals -2x plus 6. Now, what's the x-intercept of this line? The x-intercept occurs when y equals 0. Well, the x-intercept is then where the graph crosses the y-axis, because that's where y equals 0. So here's the x-intercept. What is the x-intercept? We can estimate. To estimate, we draw a vertical line through the point. We would normally draw a horizontal line through the point, but it coincides with the x-axis. Well, we might as well do that anyway. Here's y equals 0. Here's x equals what? X is 0 here, x is 4 here, right? Are we closer to 0 or are we closer to 4? Well, we're closer to 4. How much closer? Does it look like this might be like x equals 3? Maybe. Although if I cut the interval from 0 to 4 in half, and you should be used to cutting things in half, you see that we're closer to x equals 2 than we are to x equals 4. Now, if you've done all the labeling I've asked you to do, it's just second nature. You know that this is a line x equals 2, this little dotted line I drew here. If not, well, learn to do it. Because it gets you oriented to the graphs and it lets you see things in the graphs that you wouldn't otherwise see. So I think it's a little less than x equals 4, x equals 3. I'm going to say x equals 2.5 with a question mark. Well, how do we find the x-intercept? Anytime you see the terms x-intercept or y-intercept, you don't just look at the terms and stop there. When you see x-intercept, you think y equals 0. If you see the term y-intercept, you think x equals 0. Okay? That's something that confounds students throughout the whole pre-calculus course because they won't remember what I just said. What I just say. Just make sure, you might have been thinking about something else when I said it. When you see the word y-intercept, you think, x equals 0. When you see the word x-intercept, you think, aha, y equals 0. Okay? And you think that instantly. That's an instant association. If you don't have that instant association, you're going to stumble. And you're trying to solve a problem, you don't want to be stumbling. It's like you're trying to run across this field to get away from that bull that's chasing you, and you stumble over a rock and it doesn't turn out well for you. Okay? Now maybe the bull's actually friendly, just wants to come up and lick your face or something, which is bad enough. Okay. Big old slobbery bull. Yes. Okay. X-intercept occurs when y equals 0. I don't know if I said that. Okay. It just pops into my head and no filter. X-intercept when y equals 0. Don't laugh out loud. You laugh out loud. Okay. Unless you got a Van Kieser laugh, nobody's going to identify. Okay. X-intercept and y equals 0. We're trying to find the x-intercept. We estimated that it's 2.5. So we say, well, okay, y equals 0, y equals 0. Now, according to the equation, 0 equals negative 2x plus 6. Okay. So now what? Well, we solve. We do 0 minus 6 equals negative 2x plus 6 minus 6. We get negative 6 equals negative 2x. We divide both sides by negative 2. So we get x equals 3. Well, there, you showed me. Because y'all wanted to say that was x equals 3, and I said, no, it's closer to 2. Okay? Well, that's because my graph wasn't perfect. I mean, I knew that x was going to be 3. And I didn't know that my graph wasn't going to really show that. But when it didn't, I went with it. Okay, so we estimated x equals negative 2.5. But when we did the algebra, we found that in fact it was 3. Okay? So that's not that, and it's not negative 2.5. I got that negative sign, but pre-loaded, no filter. Okay, x equals 3 compares favorably with the x equals 2.5. Actually, the 2.5 compares pretty favorably with x equals 3. It means my graph wasn't perfect. First time ever that happened. Okay, my graph wasn't perfect, but it was close enough to give us a plausible result, and we sort of believe this, okay? If you want to really believe it, plug x equals 3 into here. -2 times 3 is -6, and b is 6. Now there's our equation. Okay, plug in here. And you got it. Now, of course, we took this equation here and used it. 1 equals 0. All right. Does that make sense? That should all make sense. To the extent that you've mastered the stuff you're supposed to master, it should make pretty good sense. And if you haven't, there's still time. It's not that hard. Just do it. Okay. Going to read the first problem, okay? First problem on this assignment, these numbers are randomly generated. Find the slope of the line that goes through the points -9, -15, and -8, -13. Can you do that? How are you going to do it? You're going to do it with a fundamental triangle. You're going to sketch those points. You're not going to use a formula. Then you're going to use a formula and see if it works. And then you'll understand it. Make sense? Sketch it. Don't just use a formula that doesn't have any meaning. And when you really understand the meaning of the formula, then you can start using it as long as you're visualizing what it means. Visualize where the points are, visualize a fundamental triangle. I'm going to ask you to sketch the thing. Okay? So be sure you're able to do that when you come in next time. That's the beginning of wisdom in this section. And then it gives you a graph with a grid and asks you to find the slope. You know what you're going to do? You're going to sketch that graph and you're going to sketch 2 points on it and you're going to make a fundamental triangle. Okay? I can't check to see whether you do that or not. But as I said in class last time, I want you to be writing out your work on these assignments. And I want you to bring it with you in class. Not so I can get after you if you don't do it, but so I can see what you're thinking and what you're doing so that I can address difficulties that I see, because I don't know where you're reaching stumbling blocks. Although I think for most of you, the big stumbling block is you just haven't had enough time to do it. Okay? You're smart. You can make up for that. You can still reconcile this, but you need to do that. Okay, now, would you say that this is an increasing or decreasing function? This thing here. I think I'm just increasing or decreasing. Does it mean you don't like it, or is it decreasing? Probably both. Okay, it's decreasing, right? And if it was like this, it would be increasing. That's a third problem. Okay, now there are a bunch of them. Now the fourth problem gets into something that you need in order to actually apply this stuff. A plant grows linearly in time. I can immediately say, okay, that means I've got y equals the height of the plant, if that's what we mean by grows. Okay, not the weight, the height. Okay, but maybe we mean the weight, and we say it more specifically: x equals time. Okay. The plant is 6 centimeters tall after 20 days. And 10 centimeters tall after 40 days. Okay. Those are 2 points on the graph. What point on the graph would correspond to the plant being 6 centimeters tall after 20 days? Well, you don't need to know what point it is. You say 6 centimeters. Okay. Now, is that the height or the time? That's the time, right? 6 centimeters. Clock runs in centimeters. Okay, well, no. Time runs in other units. And in this case, it'll be days because that's the way I'm giving you the information. So you got y equals 6. And then you got y equals 10. Anything difficult about that? Except maybe the fact that when you see something in words, you translate it to a graph. And that's not difficult. Okay. Okay. My biggest time is 40 days, so I'm going to put 40 out here. And x equals 20. Well, that'd be halfway to x equals 40. So I guess that makes sense to put x equals 20 here. And now I've got 2 points on the graph. Now I've got 4 points here. 1, 2, 3, 4. Only 2 of them correspond to this situation. Which 2? On the left, will be lower left or upper left? Will be this point or this point? Well, look here. 6 centimeters, 20 days, right? Where's y equals 6? Where's x equals 20? Where do they meet? Lower left or upper left? Well, if x is 20 and y is 6, x is 20 on this line, y is 6 on this line, that puts the point here. Okay. 6 and 20 go together, and 10 and 40. So here's 10, here's 40. There it is. Here's our fundamental triangle we label it. Okay. The rise is what? 4. Meaning 4 centimeters. A run. And we put the arithmetic there, but we get 20, meaning 20 days. Slope is then going to be, and write this out, slope equals rise over run equals 4 over 20 equals 1/5. And we put 1/5 here and put a box around it. Now we know the rate at which the plant is growing. Okay. And if we know a little more, we can find the equation. Okay. Now, the little more that we need to know is the slope intercept form, and we don't have time to do that today because we had to do a bunch of other stuff that really shouldn't have had to do, but we need to keep the course moving. So the first thing you do when you have a word problem with information like this is you put it on a graph. Okay. Now, well, it's actually 1221, but let's see. Okay, now there's more that you need to know. But the videos and the open math materials will get you there. That's the first 4 problems, and there are a total of actually 12 problems. But that should get you a good start. Wrong course, wrong course. Now we have a whole section on inverse functions. And we haven't been able to talk about that. But I want you to be sure you read that so that next time I can go over it rather briefly. And it's going to be due, instead of Saturday, it's going to be due next Tuesday. So be sure you read and attempt some of the problems in that section so you'll be prepared. Okay? Okay, very good. So y'all have a great weekend. Get some stuff done. Let me turn Zoom off so you can make faces at the camera.